Hello friends, in today's video let's solve Geeks for Geeks problem of the day, which is minimum exchange. So we are given a matrix of size n cross m, and every cell of matrix contains either A or B, and an exchange is defined as swapping of characters between two cells. So our task is to find the minimum number of exchanges needed to rearrange the given matrix such that no adjacent cell contains same characters. Okay, and two cells are adjacent if they share one of their common sides. Okay, so initially this problem looks a bit difficult to understand, but see, let me take the test case and explain it to A, B, A, and B. So this is the input matrix which we are given, and we need to find how many swappings are required to make a matrix such that none of the adjacent characters are same. Okay, so see, this question can be solved. It is tagged easy, yeah, but see, there is one simple thing which we need to know. Okay, so what is it? See, we are told that we do not require any adjacent same characters, right? None of the characters in the adjacent should be same, and the matrix is consisting of A and B only, right? So see, one idea which comes to my mind is that, see, if I construct this matrix A B, B A, and AB. Okay, so see, this matrix has no adjacent same, right? Because we are not considering diagonal, right? We are considering only a four sides, which is left, right, up and down. Okay, so this is a matrix which has none of the adjacent characters same. So this is a probable. We could make this matrix to this one, right? Another case is that I start with B, so BA, then AB, and then BA again. Okay, so this is again a possible matrix, right? So what we could identify from this is, see there are only two possible answers where the adjacent characters are not same when we consider four sides. Okay, let's say our n is 3 and m is also 3. Okay, so what are the two possible answers? One is ABA, BAB, and again ABA. So this is a possible answer, and another possible answer is BAB, ABA, and again BAB. So these are the only two possible choices which we have, which does not contain any adjacent characters same. Okay, so these are the only two possible choices. You could check for all of the cases, and you could check for more cases also. You would see that only these two are the possible answers, right? So that means, if I am given an input like this. Okay, so see, I could make this matrix into the one part or another part, right? See, one thing I could make is like this, or the second possible would be this. Okay, so see, now we are told that we can swap any two characters, we can swap any two adjacents, okay, that is called exchange, right? So we need to find the minimum number of swappings, minimum of swaps. Okay, so see, we know the end result, right? We know the end result that after doing any number of swaps, our final result can be this or this, right? So that means why I could start from back and then check whether it is possible. See, if I want to convert this matrix to this matrix to this, then how many swappings are required? See, swappings would amount to the unmatching characters, right? The non-matching characters. So see, here B is required, here A is required. So I have, from first row I have 2, then here A is required. So from the second row is here 2 again. Here B is required. Okay, and the third row is same. So for this, for this matrix, if I want to convert to this first one, I require 4 swappings, 4 exchanges. Okay. And if I want to convert to this, then see, in the first row I have how many unmatching characters? 1. In the second row again I have 1, and in the third row I have all unmatching. So if I want to convert to this matrix, I would require 5 swappings. Now I would take the minimum of both of them. So what is my answer? 4. So within 4 swappings I can convert this matrix, this is the input matrix, to this matrix, and this matrix I am pretty sure that this matrix has no adjacent characters are same. Okay, this is means I know this because this is the matrix which I could form. Okay, so that means see, now we let's come directly to the solution part. I hope you have got it, and in case you have not got it, comment it down. Okay, this, what is the solution? See, there are two possible, we could do two possible solutions. One is the brute force. I would not brute force exactly, but which would take big of n cross m space complexity. What I could do, see, as I told you, I am given the n, the dimensions of the matrix are given to me. Okay, so then I could make two matrices, right? What are the two matrices? AB, sorry, ABA, we are given rows as 4 and columns as 3. BAB, again ABA and BAB. So this is first matrix which I could form, and this is the second matrix which I could form, BAB, ABA, BAB and again ABA. Okay, so these two matrices I could form, and then I would find the number of unmatching characters for this, and independently for this I would maintain one count variable C1 and count variable C2, and finally I would return the minimum of count. What is count? Count is the number of unmatching characters when we compare with our input matrix, right? So so this is the I would say big of this would take space complexity of big of n cross m, because I am forming these two matrices, right? See, this is one way, means I am given the dimensions, I would form this matrix. See, then again how would I form this matrix? See, it is very easy. If you go over to the coordinates, see 0 1 0 2, this is 1 0 1 2 0, this is 3 0. Okay, and similarly for others. So see, if I could check if I plus j is even, then one time I would place A and another time I would place B. Similarly, see, you can see 0 plus 2 is even, then I would place A, and for this case 0 comma 0 is B and 0 comma 2 is also B. So one time I could place A and another time I could place B. So it is as simple as that. So if my I plus j is even, then I could place A one time in first matrix and B in the second matrix, right? So now, and then I would check the unmatching characters, and that is the number of swappings which would be required. So let me go down to code quickly. So see, I am defining two matrices. I would first take the dimensions, and then I am defining two matrices P1 and P2, and I am constructing them, right? So as I told you, if I plus A is even, then in the first matrix I would place A, and in the second matrix I would place B, and similarly and else part B and A, right? If it is odd, then I would place B in the first and the A in the second, and then what I would check. And finally I would check the number of unmatching characters. So if my matrix of ij is not equal to p1 ij, which I have formed, see, p1 and p2 are the final matrices. P1 and p2 are my final matrices, which I am pretty sure that they do not contain any adjacent characters. Okay, any adjacent same characters, any adjacent same. So this I know, and the end result I know. That's why I need to check how many there are unmatchings in p1 and p2. And so finally then I would return minimum of C1 and C2, which is my answer, and let me try to submit it. I would paste the code in the description, don't worry. And okay, now till it is running, let me quickly show you the second case, means what we could do in the second case. I would mean big O of 1 space complexity. So see, in this problem only I told you that let's assume that these are the coordinates. Sorry, it is 1 0 2 0 and 3 0. Assume that these are the coordinates. Okay, so now one case is that I know that I would place a over here, right? If it is a even number, if my I plus a sum is even, then I would place a, or another case I would place a b. So instead of forming the matrix, I could directly check that if it is a and if it is a b in case of matrix of ij, what is the minimum number of swappings required. Okay, so see, this code this ran successfully. Now let me show you the big O of 1 space code. Okay, let us see that. Yeah, probably this submission has that. Just a minute, it is loading. Yeah, see what I have done. See, there are two cases. Okay, so I have taken the nm as the dimensions of matrix. I have taken two variables. These are not required actually. Let me remove them. So this is p1, p2, p3 and p4. Okay, so see, if my I plus j is even, and I am checking that if matrix of ij is not equal to a, then I am incrementing my p1. Okay, and on the other hand, if I am also checking that if my matrix of ij is a, then I am incrementing my count. Okay, so what it is doing, let me see what this is doing, right? So let's say my matrix is ab, ba. Okay, so this is the case. Now initially I am checking that if it is an even, if my I plus j is an even sum, it gives me even, Then I am checking if there is a present in my matrix and if there is a b present in my matrix. Okay, so if there is a present and c, okay, so let's consider this case because this has adjacent same and this has not, right? So see, I could make these two matrix, right? These two are the possible answer for this matrix, right? So then I am checking that if my I plus j is even and I have a initially at this position and I also require a, so then I would not increment my count. Okay, and else if it is not an a, then I would increment my count, correct? And similarly, similar is the case with b. And finally I will have two variables p1 and p2 for the first matrix, means how many a's and b's are placed correctly. And similarly I have p3 and p4 variables for this matrix. Okay, so that's why I am having two loops, and correspondingly I am incrementing p3 and p4, and then finally I am returning the minimum of both of them. Okay, see, in case you are not getting how I am working this, see what you could do. You take one matrix ABA, BAB and BBB, okay, and then you check, see, you name it, you take a pen and paper and then you name it, right, like this 1 0 2 0 and 3 0, and then you try to figure it out. See, that's why I told you that first look at the brute force solution or the space complexity order of n cross m solution. Okay, once you understand that, then you would definitely understand this problem. This is all of the logic of coordinates only, right? And nothing there is rocket science in like this. You could understand it once you go through both of the codes. Okay, so I would paste the both codes in description, and if you like the content, do not forget to subscribe to the channel and like the video. Yeah, thank you.